Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am your chemistry teacher here. Today we are going to discuss the third chapter, which is about the periodic table and the periodicity of the properties. But before study the periodicity of properties, first of all we discuss the history about the periodic table. So the need of classifications means that initially the number of the elements was limited, so it was easy for the chemists to study these elements individually. Means in the initial the elements are limited, so the scientists study these elements easily, but with the passage of time the number of elements increased. But with the passage of time this number of the elements was discovered increased. So as in 1800 only 34 elements were known, but the year 1870 this number increased to double, and in 1974 it's rise to 105. Means that in the 1800 only 34 elements was discovered, but the year 1870 this number is increased to double, and in 1974 it's rise to 104. So for that purpose the need of classification is important, so it become difficult to study them, so it was felt to arrange them properly to study them easily. The development of the periodic table started in the year 1800. So in the year 1800 the development or the classification of the element was started. Many chemists classify it in different way. Many elements classify these elements into different ways, like the some of the attempt are as follow, like the Lavoisier in 1787, Newlands 1864, Dobereiner in 1817, Mendeleev in 1869, Moseley in 1913. So we discuss these scientists' contributions and how they arranged these discovered elements. So we discuss one by one. So in this case they arrange or organize these 105 or 65 elements. Categorize means that the classification of elements, and this classification is based on the categorizing element into groups based on the similarities and the differences in their properties. So the stepwise development of the periodic table, like the first one is the Dobereiner's law of TRAIDS, Newland law of octaves, Mendeleev old periodic table, and the Moseley modern periodic table. So we discuss these contributions of the different scientists one by one. So in the first case, the law of TRAIDS, which is given by the Dobereiner in 1817. J.W. Dobereiner, a German chemist, classified chemically similar elements in the group of 3 on the basis of their atomic masses. He classified the elements on the basis of their atomic masses. These groups are called TRAIDS. These groups are called TRAIDS because they made group of 3 elements. TRAIDS mean that they consist of the 3 elements. So they made a group of 3 elements. In TRAIDS, the atomic weight of the middle element in this group, the atomic weight of the middle element was the arithmetic mean of the atomic weight of the other 2 elements. Like for example, we can take the example of the TRAIDS, like in the middle one is the atomic weight of the terminal elements present. Like the atomic weight of the sodium is 23. How we can find out this sodium 23? So we can take the terminals elements like the lithium and the potassium. Lithium atomic mass is 7 and the potassium is 39. When we add these two and divided by 2, so we can calculate the value 23. So 23 is the middle value. So we can define that in TRAIDS the atomic weight of the middle element was the arithmetic mean of the atomic weights of the other 2 elements. Means that in the middle sodium value was the arithmetic mean of the 2 elements like the lithium and the potassium. We can take another example like the Dobereiner TRAIDS. They made group of 3 elements and they found the atomic weight of the middle one by the arithmetic calculation of the 2 elements like the calcium, strontium and the barium. So how we can find out the atomic mass of the strontium? So we take the terminal elements like the calcium and the barium. So calcium mass is 40 and barium is 137. So we can add and divide it by 2. So we can find out the 88.5. So this 88.5 is the atomic mass of the strontium. So it's called the law of TRAIDS, means that they made group of 3 elements. Then the law of octaves. Then the law of octave means 8. That the TRAID means 3 and the octave means 8. In 1864, an English chemist, J. Newlands, classified the element in order of their increasing atomic masses. He also classified the elements in order of the increasing atomic masses. He classified the elements into the group of the 7 and found that every 8 element has the property similar to the first one of the series. Means that he classified the elements into period, and this period consists of the 7 elements, and he found that every 8 element has the property similar to the first one of the series. He called these groups called octaves, means that the 8 one have the similar properties like the first one. Like the lithium resemblance the sodium and the fluorine resemblance the chlorine. Means इन्होंने क्या कहा था? इन्होंने कहा था कि आपके पास जो लिथियम है, बेरियम है, बोरॉन, कार्बन, नाइट्रोजन, ऑक्सीजन एंड फ्लोरीन, ये 7 एलिमेंट्स है। 7 एलिमेंट्स इन्होंने कहा अरेंज किए थे, पीरियड में अरेंज किए थे, ठीक है। तो इन्होंने कहा था कि जो आपके पास 8 जो भी एलिमेंट आएगा उसकी जो प्रॉपर्टीज़ होगी वो सिमिलर होगी टू द फर्स्ट वन। अगर इस सीरीज़ में हम लोग देखते हैं तो लिथियम है, बेरिलियम है, बोरॉन, कार्बन, नाइट्रोजन, ऑक्सीजन एंड फ्लोरीन, 7 हो गई, ठीक है। अब 8 क्या है? सोडियम। 8 क्या है? सोडियम। अब सोडियम की प्रॉपर्टी सिमिलर है किस चीज़ के साथ? लिथियम के साथ, इसलिए इनको एक ही ग्रुप में रखा, ठीक है। अगर हम लोग 1 2 3 स्टार्ट लेते हैं बेरिलियम से, तो बेरिलियम से अगर हम लोग देख ले तो 1 2 3 4 5 6 7 और 8, तो मैग्नीशियम पे 8 आता है, ठीक है। तो मैग्नीशियम पे 8 आता है, तो इस वजह से इन्होंने कहा कि बेरिलियम और मैग्नीशियम की प्रॉपर्टी सेम होगी। अगर थर्ड में देख ले, अगर हम लोग कहते हैं कि हम लोग बोरॉन लेते हैं, ठीक है, बोरॉन में हम लोग 1 लेते हैं, तो उनकी प्रॉपर्टी बोरॉन का 1 लेते हैं, तो बोरॉन का हम लोग जो स्टार्ट करते हैं बोरॉन, कार्बन, नाइट्रोजन, ऑक्सीजन, फ्लोरीन, तब 8 कहाँ पेगा? एल्यूमिनियम पे। तो इस वजह से उन्होंने कहा कि हमारे पास 7 एलिमेंट्स हैं, हमने पीरियड में अरेंज किया है, और जो 8 आता है तो उसकी जो प्रॉपर्टीज़ होगी, जो फिजिकल और केमिकल प्रॉपर्टीज़ होगी, वो सिमिलर होगी टू द फर्स्ट वन ऑफ द सीरीज. So the lithium resembles the sodium and the last one the fluoride resembles the chlorine. So it's called the law of octaves, means that it consists of the 8 elements. Then John Newland law of octave, he arranged the elements in order of the increasing atomic weight or atomic mass. Every 8 known element had similar properties and the chemical properties. Every 8 element has the similar properties of the similar physical and chemical properties of the series. Then we discussed the failure of laws. That this law was failed. They failed to classify all the elements in the same manner, so both the laws of fail. So means the law of octaves and the law of Dobereiner was failed. So then the MENDELEEV'S periodic table. The elements, if arranged according to their atomic weight, exhibit an apparently periodicity of the properties. So we discussed the contributions of the Mendeleev periodic table. In 1869, two chemists, Luther Meyer in Germany and Dmitry Mendeleev in Russia, at about the same time independently developed very similar arrangement of the element. These two scientists arranged the similar elements. So we discussed the contributions of the Luther Meyer and the Mendeleev one by one. In the first case, the Luther Meyer compared atomic masses of the element with their physical properties like the density, volume, and the melting point and the boiling point. Means the Luther Meyer compared the atomic masses of the elements with their physical properties. They also take the atomic masses but compare with the physical properties like the density, volume, melting point, and boiling point. And he also made a graph between the atomic masses and he take the density or volume. Luther Meyer plotted atomic volumes, densities of the element against their atomic masses and found that similar elements occupied similar position in the graph. So in the graph we discussed that we can discuss that Luther Meyer made a graph between the atomic masses and the density. He take the atomic masses on the x-axis and densities on the y-axis, and they made a graph. And they found that on the peak, that every peak the element consists having the similar properties, that in every week the element consists have the similar properties. Then Mendeleev, in arranging the elements in order of their increasing atomic mass, Mendeleev also arranged the elements in order of their increasing atomic mass. Certain physical and chemical properties are repeated at the regular interval. Means that Mendeleev arranged the elements according to their increasing atomic mass, and they take the physical and the chemical properties are repeated at the regular interval. Means at a specific interval these properties of the elements are repeated. Mendeleev arranged the elements in the form of a table. For the first time, Mendeleev arranged the elements in the form of a table, in the form of a periodic table. He arranged 65 elements in periods and group. He arranged these 65 elements which were discovered at that time in periods and groups. In this table, he left vacant spaces for the elements which were not discovered at that time and to be placed in these vacant spaces. Means that he left the vacant spaces for the elements which were not discovered at that time, and they also on the basis of this table he predicted that the properties of the elements very accurately that were not to be discovered. Means he predicted the properties which are very correct or without any error. Then Mendeleev arranged 65 elements into the periods and the group, and he also left the vacant spaces. You can see that these are the vacant places in the periodic table. Failure means that Mendeleev classify was based on the atomic mass. Its classification was based on the atomic masses, and atomic masses was so many errors. However, it's the discovery of the atomic structure. When the atomic structure was discovered, so we know that the atomic structure consists of the protons, neutrons and the electrons. It became clear that the elements vary regularly with the atomic number, not with the atomic mass. It had also become known that the properties of the element depends on the number and the arrangement of electron in each of its atom. Means we can know that in the outermost shell that the electron consists. So the arrangement of the electron depends on the properties, on the physical and the chemical properties. Thank you for your attention.